computer.
Okay, that worked.
Okay. Hopefully you all saw some kind of like you're being recorded
It's
warning
audio. Yeah.
and uh it seems like we are recording.
Mhm.
All right.
All right, so we'll get started. Reinhard, you keep an eye on the chat in case anyone has questions. Feel free to
Mhm.
ask questions anytime during, and we will also have the Q&A at the end where we won't be recording. So either way is totally fine. So we're going to do a hands-on workshop tonight if you want to follow along on your own computers or if you want to just sit back and watch, either way totally works. Our goal tonight is to give you a sense of what we have on our open data portal online and what you can do with it. Um, so like I said, feel free to ask questions at any time or save them up for the Q&A at the end. Um, so let's get started here. So let's start with who we are. My name is Alex Epstein. I'm the systems data analyst in the open data department. I used to be a college librarian before I got into this. I also have a little bit of a background in public health. So my whole career is sort of around data information and connecting users with that information or that data. Um, and I also love running and trivia and crossword puzzles, all kinds of nerdy pursuits. You want to introduce yourself, Rainer?
I'm Reinhard Engels. I'm the Open Data Program Manager. Like Alex, I am also an ex-librarian, and I kind of feel like that makes sense. It's kind of a similar kind of mission that we have of making knowledge available to the public. I did bioinformatics visualization at the Broad Institute for a bunch of years as a software engineer. So visualization is an aspect that is particularly interesting to me. And then I also did library technology at Harvard, at the Harvard Library, and also at the Cambridge Public Library. And yeah, and then one big aspect of this talk here is not just to show you all the cool technical bits you can get, and there are going to be a lot, so it's really more of a tour than a deep dive, but to make sure that you know who we are, so if you have follow-up questions, you know who to reach out to. And we highly encourage you to do that. So,
Yeah, definitely. Okay, so let's get started. We'll start really basic here with just a definition of data for our purposes. Um, so for us, we think of data as just information, usually in the form of numbers or facts, which can be used to analyze something or make decisions. And in our case, since most of our data is city data, um, that analysis or those decisions are usually city decisions. So policy decisions or decisions about something that's going on in the city of Cambridge. So that's usually what we're talking about when we're talking about our data. And so then from there, what do we mean when we say open data? And what's the difference between open data and public data? So open data here you see our definition, but the difference for us between public data and open data, when we think of public data, we think of data that people have the right to access and it's out there, but it's not necessarily easy to get at. Maybe it's in an office somewhere that's not open all the time, or it's not in the language that you speak, or it's very technical. You need to have certain computer skills to get at it, or something like that. When we try to make data open, which is what we do every day at our jobs, what we're trying to do is make this data, which is public, as accessible as possible to everyone. And it's free and it should be able to be used however you want without restriction. You should be able to use it to do your research or to, satisfy your curiosity or to write your report or whatever you're doing. And we try to make it as accessible to everyone as possible, whatever your technical knowledge is, um, whatever age you are, whatever your situation is. And so that's our goal. And that's what we mean when we say open data, as opposed to public data, as opposed to free data, anything like that. So that's our sort of ethos in the open data department here. So the open data program, which is what we call our department, which is just me and Reinhard, that's the whole department. Here's a little description, sort of our mission here, which is, transparency. It's that accessibility that I was talking about. It's really sharing that data and at the same time keeping that balance of making everything as open and accessible as possible and also keeping privacy in the front of our mind. So we would never want to share data that compromises anyone's privacy. So we're always trying to keep that balance. So that's the open data program. Okay, so what we're going to show you tonight is what we call the data portal. And that's where we keep almost all of our data. And that's where we try to make it as accessible as possible. So there's a couple ways to get to it. You can just Google Cambridge Open Data and that'll come up. Or you can go straight to the website, which is data.cambridgema.gov. And you can see it written here on the left. And here's a screenshot of the Open Data Programs homepage where you can see different news, what we have going on, some different stuff you can read about our program. And then the main thing here, the first thing you see is a link straight to the Open Data Portal. So I'm going to open a new tab here and I'm going to go to data, if I spell it right, data.cambridgema.gov. And here's our website. And then if I just click on Open Data Portal, it'll take me right into the portal, which, as I said, is where we keep our data. So here it is. This is what it looks like when you get into the portal. And what you see first is a list of different data sets or assets that we have here. And the reason you see this COVID thing first is that they're arranged, and this is just a default arrangement with the vendor we have. They're arranged by lifetime popularity. So popularity of all time. So this is how many views these things have had, and just by all time, not by this week, not by this month or this year. But COVID cases has had 409,000 views over the course of forever. And the next most popular one, which is the salaries of people who work for the city of Cambridge, which is very interesting, has had, 51,000 views. So that's an order of magnitude different. And it's just, we're never going to catch, this one's never going to catch up to that one. So that's just going to be on top forever, even though no one's really looking at this one anymore. So that's just how it is. But anyway, so we have different kinds of what we call data assets. Most of them and most of what people come here looking for are data sets. And you can see that listed under the types of data assets we have here, data sets. And that's what people usually think of when they're thinking of open data. It's in the form of what you would think of as a spreadsheet, a table of data. We also have other kinds of things like, charts and maps and different kinds of stuff. And I'll show you that a little bit later. But at first, we'll just focus on data sets here. So this is a data set. This is a data set. When it has this little pile of circles, which I think is a very old school way of doing maybe a hard drive or something. It's a data set. This is a data story, but a lot of these are data sets. These are all data sets. So we have a lot of data sets in here. And these data sets are organized in different ways. Each one has one category, and that pretty much maps onto a department. So you can see this police department crash data set. The category is public safety. Same thing for these crime reports. The category is public safety. For this budget one, the category is budget and finance. This COVID one, the category is public health. So each data asset has one category, and that's usually the department that generates that data or houses that data. Each data set or asset might have many tags. It can have an unlimited number of tags. One category, unlimited number of tags. And here's the tags. Here are the tags down here. So you can see the tags here. So that's sort of how we organize and categorize these things. One category, unlimited number of tags. So that's just another way you can search. And there's a search bar up here, and you can search for something that you're interested in looking up. So I'm going to show you a particular data set right now. I'm going to put building addition because I want to show you this data set. This one is building permits. We have a lot of different building permit data sets because you need some different kinds of permits when you want to build something in Cambridge. This one is for permits for doing an addition or alteration to a building. Okay, so if you click on a data asset, in this case, a data set, what you'll come to is this landing page about the data set. And what you see here is all kinds of information about the data set. So we call that metadata. And some of you may have heard that word before. Meta means like a level above. So what we're talking about here is data about the data. So it's information about this data set. So we have the title of the data set, we have a description of the data set, when was it last updated, who provided the data, and then all kinds of other information about this data set. So how often it's updated, how many views and downloads it's had, when was it last updated, and its category and tags. We have a license that we put on any data set we can, which just, it's a legal document that shows what permission you have. And this open data license gives you permission to do anything you want legally. It says you have permission to use this data in any way you want without restrictions for free, which is really good because legally you have that right. And more metadata here. It tells you how many rows are in this data set. So that in this case, each row is one building addition or alteration permit. So you think of all these permits listed down in rows. So this has 13,000 permits listed and 121 columns. Those ones go across. So each column, they're listed out here, is a different piece of information about that permit. So when was the permit submitted? When was it issued? And then all these little pieces of information that you need on this permit. So how much was the gas cost? How much was the total cost, the fire prevention costs? And you got all these little bits of information. And some of our data sets do have hundreds of columns. Some have 5 columns. They're obviously all very different depending on what the content is, right? So this has things like describe the outbuilding, because that's a building permit and you need all this information. Okay, so you've seen all this metadata. This is all kinds of information about the data set. So let's take a look at the actual data. So you go up here in the left and you can just click data and it'll take you to the actual data set. Now, like we said, there's thousands and thousands of rows here. I think we said 13,000. So this is just the first 50, I think, that we're looking at. And you have all this information. And remember, there's over 100 columns in this data set. So this goes across far, you can just keep scrolling across. There's a lot of data in this data set. So obviously no one's coming to this data set to just sort of read it like front to back, like a book. That wouldn't make sense for anyone. There's a lot of data here. That wouldn't be interesting. So usually you're looking for something, you're either looking for a particular thing, if it's maybe your building that you're working on, or you're interested in something going on in your neighborhood or something like that. Or you sort of are wondering about trends, or you're wondering about, what's going on in the city. So there's a bunch of different ways that we can explore that. So the first thing I'd like to show you is how to create a visualization. Reinhard was talking about how he's done visualizations a lot in his career. So visualization, as you can imagine, is a way of making the data something that you can visualize or look at. So if you go up here to this big blue actions button, one of the actions here is visualize, and you can choose create visualization. So I'm going to show you a couple different ways to do that. So it's asking me if I want to sign in. The only reason you need to sign in, and you can make a free account here on this, which is called Socrata. It used to be called Socrata. It got bought by a company called Tyler. So it's sometimes still called Socrata, sometimes Tyler. You can make a free account on here really easily. And the only reason to sign in is if you want to save the visualization you make. In which case you need an account to save it, which would be great. So I think I will sign in because I'm going to show you guys how to save it. So I have an account already. So I'll just sign in. All right, so I'm signed in now, and it says select what kind of chart I want to make. So I'll start with a bar chart. I call it a bar chart. They call it a column chart. Either way. So the default thing that they want to make this chart out of is just addresses, which if this loads, I'll show you how silly that would be. But it's a lot there. Yeah, it's a lot of addresses. So it's just showing me how many permits for every single address that has a building permit. So that's not, I don't think that would be useful for anyone. It's certainly not useful for me or interesting. So instead of doing that, I'm just going to see how many permits over time. So I'm going to choose date, if I can find issue date in here. These are in alphabetical order. So I'll go down to issue date, the date the permit was issued, and the measure, so how high the bar will be count of rows. And remember, each row is one permit. So the count of rows is the same as the count of permits. So you can see here how many permits were issued in each month. And you can see March of 2020, April of 2020, the famous COVID thing that happened. So you can see that happened, and then we got back in business and kept going after that in a sort of seasonal way. So that's one thing you can do to sort of look at trends over time. And there's plenty of other things you can do. You could, instead of looking at just how many permits there were over time, you could choose something else, like how much did it cost over time? So you could go to total cost to do these additions or whatever. Now it's the automatic default here is that it's set to sum. So this is the total cost for all permits for each month. So if you add up all the permits for that month, that was the total cost. I'm not interested in that. I'm more interested in what was the average permit? What was the average cost of that project for each month? So let's try that instead. So I'm not sure what went on in April of 2020. That might be, looks like it's such an outlier that there might be some discrepancy there and we should look into that. Otherwise, you can see some maybe seasonal trends. I'm not sure. So let me show you another kind of chart that I like, which is called a combo chart. So in this one, you can compare two things. So if instead of total cost, why don't we compare two kinds of costs? So let's try the cost of plumbing. And then we can add another measure. Let's try the cost of something else, maybe electricity. Yeah, so we can see sometimes these things go together, sometimes they sort of separate from each other over time, but they seem to have a trend that goes together. I don't know much about building. If I did, this might be even more interesting to me, but it's a little interesting. And then I'll show you one more type of visualization, which is a map. It looks like a globe, I guess. So if you click on that, it will make you a map. The automatic way it makes a map is to just put a point down for every single thing. So for every permit, it's put down a point. And as we know, there's over 13,000 permits in this data set. So it's just completely full wall to wall with points here. So that's not that useful for me because I can't really see what's going on in this map, and that's not that helpful. So maybe I will group these things together in some way. So another way to say grouping things together is aggregating them. So if we do that, we actually have some things called region maps. We can look at different regions of the city. Okay, it does default back to Seattle every time you do that. So then you have to go in again and choose what regions you want to do. So you can do any of these different regions that we have built in. So census blocks are little chunks of the city, pretty little ones. Give it a minute to load. And it also defaults to the craziest color scheme. So this is the least and this is the most, and it's just not in any kind of order, which I hate. So you can choose one that actually goes in order, which I prefer. And this is, let's see, the value here. Let's do, we can do the total cost, see how much these things are costing. Oh, and it went back to the stum color. Ugh. All right, let's try this. So this is darker for a higher number and lighter for a lower number. So these darker ones have they have higher costing additions and alterations than the lighter ones. And you can do it by neighborhood, you can do it by little zoning districts, which are also small. The neighborhoods are big. So it looks like these areas have much more expensive addition and alteration projects. But one thing I also want to point out, if we can do count of rows, let me do this up here. Well, I was doing this earlier and I found count of rows here, and there were way fewer projects going on in those neighborhoods. So I think there were just fewer projects, but they were a lot bigger. But of course, now that I'm doing it live, I can't find that. Well, you just have to trust me on that one because I'm not going to make you watch me go through that. So once you've made your visualization, if you've signed in and you have an account, you can save it. So I'm going to hit save draft, and then you can name your visualization. So I'll just call it region map, or you can call it anything you want. Probably a better name would be better. And then you can click save. And this will just be visible to you when you save it. It won't be visible to everyone in the city. Okay. And then if you wanted it to be visible to more people, you could hit publish, and then Reinhardt or I would have to approve it to be published publicly. Which just email us. We'd be happy to. We love it when people do this kind of stuff. And then once you've done that, if you want to put it on your website or in your blog or whatever you're doing, put it in your report that you're writing, whatever. You can do all kinds of stuff with it. So that's something that's pretty cool and fun to do. Let me see. A combo map. All right, that's all I have to tell you. So I'm going to unshare and let Reinhard take over for now.
All right, thank you, Alex. I will share. Okay. So I'm going to show you a couple of things. I'm going to show you one more set of interesting things that you can do on the Socrata portal directly, the Open Data portal directly. And then I'm going to show you some things you can do getting the data outside of the portal using it in other tools. So the first thing I'm going to show you then is something called query data, which lets you do a somewhat sophisticated amount of kind of data analysis right in the browser here. And you get to it. So right now I've opened one of my favorite data sets, one of many people's favorite data sets, the Cambridge Property Database. So if you live in Cambridge, how much your house is assessed at. Um, Jonathan raised his hand. Just a moment. Let me get back there. Um,
All right, Jonathan, I just turned your mute off. So if you unmute, we
go
can
for
hear
it.
you.
Oh, I just wondering, is all the data set available in the data portal could be used unrestricted?
That's correct.
Mhm.
That's
Thank
correct.
you.
Yeah.
Yeah, you're welcome.
We have a license to make this also very clear. It's a standard data license. It's called the Public Domain and Dedication License, I think,
Sounds
PDDL.
right. Yeah. Yeah.
And
It's definitely
it's a standard license in this field that makes it very clear what you can do, and basically you don't need our approval. You can do what you want with it. And the thinking behind it was that um, more restrictive licenses, more boutique licenses are kind of a barrier to people using this stuff. Some people doing research just can't work with a restrictive license like this, or if it doesn't have a license. So insofar as possible, we try to attach these PDL licenses to the data. But that's a great question. Um, all right. So the property database. So basically what this is, it's from the assessor's office. Every year we have this since 2016. The assessor goes around and they figure out how much everyone's properties are worth, and then they dump it yesterday to Open Data. And so what we're looking at here is um, the 2020 financial year 2026 property assessed values for Cambridge. And as with the visualizations, to do this interesting thing, we're going to go to the actions menu here, and we're going to hit query data. And at first, this doesn't look so beautiful, but it's pretty powerful and it's actually somewhat intuitive. It's one of my favorite features about this platform. Although, as I said, it's not beautiful. And if you don't know about it, you'd never figure it out. But now that I'm showing you, hopefully you can use it. So let's say we have this big set of data. It's a lot of rows, there are a lot of properties, and a lot of columns. Look at all these columns, right? So most of them we don't really care about. Um, and how do we sort of zoom in on something we might be interested in? So, for example, a kind of interesting starter question might be, what's the most valuable property in Cambridge, right? Maybe you have some guesses, but we can figure that out. And the way we do that is In this bottom panel here, we have these filter options and other data control options. Up here, we see a preview of the actual data. And so this funny funnel is a filter, right? You can put criteria to whittle down what data you're looking at. This funny box here, I guess, is the group and aggregate features, which let you kind of chunk up data into different chunks to get sort of summary statistics on them. And then this guy here, this strange, I don't know what that is, dark box with maybe it looks like columns. It's called the column manager. And this is where I'm going to start because what this gives us is the ability to choose which columns we see and how they sort by, which is pretty important. Since there are so many columns, I'm going to, by default, I'm going to untick everything. And then I'm only going to choose a handful of columns that I'm interested in. So I'll choose the property ID, PID, the GIS ID, which is how we map this stuff, the building number, which I'll explain why that's important in a minute, the address, the unit, if it's a multiple unit building, and then the property class can be interesting. And the year of assessment will always be 2026 in this view. So I won't add that because it's not information. Then the assessed value, very interesting. And sale price can be interesting too. And we don't have time to get into mapping right now, but if you did want to map this in the way that Alex just showed, this coordinates field would be really interesting as well. So I will apply those fields. And now we have a more comprehensible view, just a handful of columns here. Instead of, many dozens of columns, we've got, I don't know, 10 maybe. And they all hopefully make some degree of sense, right? Here's the address, here's the building number, here are the IDs, here's what kind of property it is, here is the assessed value. But the assessed value at the moment is not in any kind of order. And we want to know, well, what's the most valuable one? So we're going to change the order. So we go back into our column manager and we look for the assessed value field that we chose somewhere. Here we go. And you see how it says no sort under all these things? We're going to tick that and we're going to say sort descending. And that way the most valuable properties will be on top. And then we'll hit apply and we'll see what happens. Okay, so now you can see we have some very valuable properties, literally like $1.5 billion properties here. And you might be like, wow, who can afford that? I mean, even Cambridge, that's a lot of money. And the answer is that private colleges can afford that. And in particular, oh, I forgot to add one more field, which is really good. Just a moment. Owner name. Okay, great. So now it's not just any old private college, but President and Fellows of Harvard, right? So maybe not stunning, but you might notice something else weird. It looks like we have a whole bunch of these properties with the same exact value, right? That seems suspicious, right? How many, $1.5 billion properties does Harvard have? And the answer is that the parcel is worth this much money, but we're seeing one row per building. And so basically we're just getting this listed many, many times for all the many buildings in Harvard Yard. And so to correct for this and just see, what the whole thing is worth, we can go to our filters panel here and we can select a column to filter and we can filter it to building number. And we can say that the building number has to be 1. So this will get rid of all those additional buildings. And now we see something that makes more sense. Now we see our $1.6 building that is owned by Harvard, and we see a $1.4 billion building that is owned by MIT. That makes mad sense. Then we see a couple more expensive buildings from Harvard, and so on. So another question. All right, so Harvard seems to win the one expensive building contest by a little bit, right? what about if we wanted to ask the question, well, taken together, who has more real estate in Cambridge, Harvard or MIT, or someone else? And this is where aggregation comes in, grouping and aggregation. That's this tab, that's this little button over here, which I think my eyes are pretty bad, but I think it's a box with like a little circles in them or something. And so what we can do here is we can say, I want to group by the owner name somewhere in here. And then I want to aggregate by the um, assessed value. And I just want to sum it up, right? I'm going to add up all the values in there. And let's see what happens then. I'll apply that. So now what we're hoping for is we see everything from Harvard and MIT, but we see something a little bit different, right? I'm not seeing Harvard and MIT up here. I'm seeing different owner names. And I'm seeing way smaller dollar amounts. And the reason is, if you remember, the sort that we set before was applied to a field that no longer exists in this view, right? We have a new field called sum underscore assessed value that was generated in this process. And this is the field we want to sort by. So if we go back to that funny little column manager here, we can go to this field here, the sum assessed value. We can sort descending and apply that. And now we see something that makes sense and is interesting. Because look at this. Our friend Harvard's only in second place now. MIT has overtaken it with $8.7 billion of property. And our employer, the poor city of Cambridge, is only $2 billion of property. But then, of course, you notice there's another owner with the word MIT in it with another $1 billion. So to do a really thorough analysis, you might have to figure out, well, is MIT Real Estate LLC, is that really part of MIT? Should we count those together? It's conceivable that when all these like sub-entities are added up, that Harvard could again end up on top. But that's, I think, beyond what we're gonna be doing right now. The point is, this stuff is kind of neat. Oh, and one neat feature about this, like, you can do a fair amount right in this web interface without having to download it to a spreadsheet and do all kinds of, fancy spreadsheet ninjutsu on it. Another nice thing about this is that, and this is, let me just move some of this stuff here. Okay. Another nice thing about this is that the URL that is generated when you're doing these query things is it captures the state of all this stuff. So I'm gonna plug this in the chat, and it's a long, ugly URL, but if you click this URL, fingers crossed, it should take you to precisely the view that I've generated here. So if you spend a lot of time drilling down to a precise view that you're interested in and you want to send it to your colleagues or friends or whatever, you can just grab that URL and send it and bookmark it. And I find that a really powerful feature. All right. So the next thing I want to show you is how to get beyond our open data portal, which is a lovely place, but there's all kinds of other things you can do with our data. And let's take a look at a different data set here. So here's police department crash data. I think Alex had this up as well for one of her examples. And this is also a data set that is pretty interesting. You can see we've got a good number of views of this data, a good number of downloads. Let's say we wanted to get this data out so we could put it in a spreadsheet or run it through some other kind of analysis. Again, we go to, we go to export, not actions, export. And we get a couple of options. And the main option here is to, or the selected option is to export it as a CSV file, as a comma separated values file. And we can just download that. And you can now, once this download finishes, hopefully soon. It's not that big. Okay, good. It downloads, and now you can go ahead and open it in a spreadsheet. Okay, and so here we've got that whole data set as a spreadsheet, and you can do all your favorite spreadsheet things with it. There's another export option, which is this API option. And what this is useful for is if you are writing software, if you're writing a script in, say, Python or R or Java or some other programming language, this is how those programming languages like to talk directly to services like the Open Data Portal. And so what this gives you is a so-called API endpoint where you can query precisely this data set. And I'm going to show you just really quickly what that looks like, because I think it demystifies it a little bit. Oops, hold on. Sorry. They have two APIs, and one of them you have to authenticate with, and one of them you don't. So I'm going to show you the one you don't, so you can see something. Otherwise, they're very similar. Okay, so this now is grabbing every row. I'll hit pretty print to make that look less ugly. It's grabbing every entry in the database, and it's formatting this in this JSON format, which stands for JavaScript Object Notation. And basically, what it is it's this sort of standard format for interoperability between computer programs that they like to use. And your script will probably be much happier getting this than getting the CSV output. So good thing to know about. There are many libraries to help you deal with this kind of data. The two most common languages that are used for this kind of data analysis are Python and R, and both of them have libraries that hide a lot of the details of how to use these APIs. So the Python library is called R Socrata, and I'm sorry, the R library is called R Socrata. The Python library is called Socrata Pi, I think. We have links to them in the slideshow that we're going to make available to you at the end of the presentation. So if you want to go explore that further, please do. All right, so getting stuff out. There's yet another, I'm just going to mention this really quickly, but there's yet another API way to get things out called OData, which is another kind of JSON data, but other different tools prefer it. Most notably, the tool Tableau prefers it. So if you like to make online visualizations using Tableau, which is powerful and free on open data, this is the URL you want to feed to Tableau. Also, tools like Excel and Power BI also like OData. And what's nice about using these API URLs is that you can then create these live links in these programs, right? So that if you want to get updated data, you don't have to download your CSV and re-upload it into Excel or whatever your tool is. You can just tell your tool, hit this URL again and get the latest data. So that is why that is useful. Okay. So another thing people are increasingly doing with open data, myself included, is using AI tools. And there's a lot of ways to do this. But the most simple, straightforward way is just using one of these chatbots like ChatGPT and saying, uploading a data file and saying, hey, can you tell me something about this? So let me show you what an example of how to do something here with this crash data set that we just downloaded. So I started, if I can find where I started. Okay, so my question was, please help me understand this Cambridge crash open data set. Please explain trends over time and any surprising results. Please use graphs and charts to help me understand. Please express numbers as normal numbers and not as scientific notation because I have trouble reading that. Um, and so I uploaded the CSV file. I did this in advance of the program because it can take a little while, and I didn't want you just waiting for all this stuff to happen. If you're curious about what the beginning steps look like, I can kick a similar one off when I'm done talking through this. But I just wanted to kind of quickly show you the kinds of things it can do. Um, I don't even know if I've looked at this result yet. I just ran it before the class, so I may be surprised as well. So there's different modes that these AIs have now. You may not be aware of this. The smarter ones tend to have the word thinking behind it. So what that, and that's the kind I'd recommend for data work. Basically, the trade-off is if you do instant or non-thinking, it answers really fast, but not necessarily as thoroughly or accurately. But when I'm doing data work, I really kind of want the best answers it can give me. So I try to make sure to put it on thinking. There's also an auto mode where it makes that decision. That's also sometimes fine. In an ideal world, if it always made that decision perfectly, I would just always keep it on auto, but I'm not sure I trust it 100% yet. So I use thinking, which is a little slower, and you'll see what kind of stuff it gets here. So here it thought for 22 seconds, and I have it set so that it shows the details of its thoughts, which I like. It's a little bit like a sanity check. It's kind of like show your work when you're a kid in school and you're doing a math problem. So I can get a sense that it's doing something legitimate. So that always show details thing is on. And it immediately starts thinking in Python, which if you don't know Python, maybe this doesn't mean so much to you. But there are comments in here too. And even if you don't know the language it's doing this in, you can sometimes get a sense as to what it's doing and whether it's way off base. And so it's diving into the data here, and it dives for quite a while. And eventually, it's going to produce some kind of output for us. Okay, it's giving me a lot of its thought process here. Glad it's thinking so carefully about this stuff. Oh, and here we get something that's a little bit interesting here. We can at least see it's getting a table of classifications of what kinds of injuries were involved. And here we go a little further. I think at some point, hopefully we get some graphs. Um, Again, depending on here. Okay, here's another table, not the most beautifully formatted, but you can see we're starting to get some data that even here is kind of interesting and useful. Um, so by year, how many crashes did we get, right? And again, 2020 is always a great sanity check. If something's not a lot lower in 2020, we don't know if we should trust it. But we're seeing that 2020 dip again. Um, so that adds some confidence that this is actually working. I should mention, Alex and I have done this demo a bunch of times now over the years, and every time, because it goes usually a few months before every demo, the AIs have changed and our output is different. And usually we've seen in past demos some obvious mistake jump out at us, which was actually like a great, sort of teaching opportunity to highlight that these things are not perfect. I don't see anything yet. It doesn't mean there isn't anything. But they genuinely have gotten a lot better, especially in the thinking mode. All right, here finally we get some graphs. So these are total crashes over time and crashes with injuries over time. So thankfully, much less, right? So that's kind of interesting. And again, we get the dip in 2020, which sort of is a rough sanity check that this isn't just craziness that it's telling us. Then we've got crashes involving cyclists and um, pedestrians. This looks wrong here. This I don't think I think this is true. Like zero, we've never had one. I don't believe that. Something went wrong there. Um, and then fatal crashes by year. And this also looks incredibly wrong. So all that I was telling you about them getting smarter, we're not 100% there yet. Um, and then we have crashes by month. So seasonality with this stuff. Again, now I'm quite skeptical of anything they're showing me. Um, and then by hour of the day. Uh, and what is it? It went on for quite a while here. Okay. Oh, I'm sorry. What that first graph, maybe I wasn't interpreting it correctly. No? Okay. All right, because this graph seems to contradict the first graph. This graph is more like what I would expect. Um, it could be that it realized something was wrong and it corrected itself. So here we don't have zero crashes for all years. We have numbers that, again, at a glance look right, but anything produced by this that you're gonna, publish somewhere or get excited about, you've got a sanity check. Um, Sometimes, actually, if you look carefully, it'll say it made an error and is correcting it. Although I didn't see that. Um, and okay, here we get another table. Sorry, it's giving a lot more than it did in previous demonstrations, which I guess is good, but take some time. Okay. And again, here we get fatal crashes that looks real. This data looks real as opposed to those very high numbers we saw before. And again, I don't know if it just saw that and realized it was wrong and corrected itself. It would have been nice if it shouted that out somewhere, and maybe if I scroll around, I could actually find something like that. But this looks about right. The numbers are fortunately pretty small. Uh, okay, here we get an analysis errored, so sometimes that happens. And here you can see what the actual error is. Um, okay. All right, here we get a graph of days of the week crashes. Again, that looks about right. Sorry, I didn't realize this would be that long. Oh, and okay, here it now gives a human explanation versus all that code and all those charts talking through what it's found here. Um, okay, these numbers seem plausible. Doesn't mean they're right, but they're plausible. Um, as do these. Again, our 2020 dip, not dump. And 2025, right, only through October. So he was smart about that. He realized that um, we have incomplete data for 2025 because it's not over yet. Okay, and here's some of its interpretation, which is interesting. Slow decline pre-COVID. 2020 is a cliff, then a rebound. 25 is incomplete. Um, so yeah, wow, this is actually much more than it's ever given me before. If I'd known it'd be this much, I may have rethought demoing this. Um, All right, so let me scroll down a little bit more to see what we get at the end of all this. Surprising things. The COVID crater is huge. Yeah, I'm actually not surprised by that, but um, but we're now above pre-COVID crash level, so that's not great, right? We have more than recovered. Um, all right. It's not impressed with our safety record on bike pedestrian crashes. Fatal crashes are very rare. Okay. And then I'd asked it to do something else, and I got totally distracted, which was to turn it into an interactive dashboard, which I've had luck with in the past. Um, but I'm not seeing it pop up here. Let me just take a look here. Let me ask you one more question. All right. Let's see what it does with that. Oops. Okay, so here it's thinking. Doesn't sound so good so far. Anyway, we'll come back to this and see if it comes up with anything. It is when it works, it's actually quite nice. You can basically put together an interactive dashboard on the web, share the URL with people you know, and uh, yeah, it's kind of powerful. All right, we'll come back in a few moments and see if that uh, results in anything. All right. So going back to, so here's actually a screenshot oh, actually, wait a minute. Look, I have a URL. Oh, hold on a second. Open link. Okay. Thank you, Reinhard. Okay. So this was a link that I had included in my slideshow from a previous interactive dashboard that I'd created with ChatGPT um, that I called the Rodent Explorer. Um, and let me just, okay. So basically, this is something I created in a similar way to what I just showed you. That thing may actually come up with something like this for the crashes. But it spit out this interactive dashboard um, where you can kind of change some of the parameters and really explore this data here. So you can get this, it created charts for the seasonality, day of the week, hour of the day. It created this kind of somewhat horrible heat map of where crashes tend to occur. Um, and you can even adjust the resolution of the heat map. Um, so kind of sophisticated for sort of 10 minutes of banging around. Um, Uh, you can adjust date ranges. Um, so really, just having put together dashboards like this the old-fashioned way by code, um, this is kind of hard to do. I definitely encourage you to play around with it. Let me just check back really quickly to see if our friend came up with anything for the current dashboard. Okay, it definitely tried to do something here. Oh, it's still working. Okay. All right, maybe we'll come back to it after the Q&A because I think we're just about ready for that. Um, okay. Let me move all of these windows out of the way, get back to PowerPoint. Okay. So this was kind of a whirlwind tour of what we wanted to show you. Obviously, there's a lot more to all of this, but we just wanted to give you a sense of the possibilities. And also, if any of this is of interest to you, you want to learn more about how to do any aspect of this from visualization to particular data sets you're interested in to working with this stuff in AI, please reach out to us. We have our email here. We'll also be emailing you this stuff. Um, we also have a feedback form that we'd love for you to fill out. There's a beautiful QR code that Alex generated for us here. And Alex, do you have the link to put in
Yeah,
the
I just put it in the chat.
beautiful? Okay. And there's also a link in the chat. And we've discovered that if you do it right away, you're much more likely to do
Do
it
it
than if you
now.
think maybe I'll do it tomorrow.
It just takes a
So,
minute.
yep, real quick, so
Yep.
quick.
You do
So
it right now.
I'm going to do two things now. I'm going to turn off sharing, and I'm also going to turn off the recording, and then go into some Q&A. So just a moment while I do that. Stop share. Okay, and now recording is